All right, folks, it's back in action here. In the previous video, we took an equation that had been rotated, a conic equation that had been rotated, and we eliminated the xy term in those in that equation. And in order to do that, we used these two equations up here at the top, these two conversion equations, to get rid of that xy term. So what we want to do on this video is get an understanding of where those two conversion equations came from. So the first thing that I want you to do is I want you to look over here at this right-hand side where I've got this grid, and we're going to focus first on the non-rotated xy axis. And when we look at that non-rotated xy axis, we can see this right triangle that's sitting on that axis. Okay, so there's my nice right triangle. The other thing I want you to notice is that the angle, that reference angle that's inside that triangle, has both two components to it. It has the theta that rotated the new axes to the x prime, y prime, and then it has the A that is the angle that's inside that triangle. So that's going to be important to us here in a moment. What we're going to do is we're going to look at this point up here at the top, and we're going to express it in a variety of ways. That's going to help us with our proof. So the first one, when I look at that point, I can, of course, as always, think of the sides of this triangle as an xy. So we get to that point, and we can, by moving over x and up y, so we can express it xy. Then when we think back to our polar section, where x equals r cosine theta and y equals r sine theta, then we can look at the expressions up here, rewriting those x and y terms, because the x becomes an r cosine, but instead of just theta, it's this whole theta plus a, because that's the size of the whole angle, and then the sine is the r sine, and then, of course, theta plus a. Then the next thing that we want to do is we want to look at the triangle that's on the rotated axes. Okay, so when we look at that triangle, now we're looking at this one right here. And there's that right triangle. So now we have an x prime and a y prime. So the ordered pair instead of xy can also be expressed as x prime, y prime, because we're going to the same place. And then we can continue and we could convert that, and we'd have an r cosine a and an r sine a, because the angle that's inside that triangle is just the a. All right, now we're going to use these four ordered pairs that are just four ways of writing this exact same point to understand how we get to these equations right here. So let's take a look down here. Actually, we'll stop it right there. There we go. Okay, so I've already typed out the proof, so we just want to follow along and where I got all of my parts. So this is what we're ultimately trying to get to. So when we can get to x equals the x prime cosine theta minus y prime sine theta, then we know that we're done. So let's start with what we know. We know that x equals r cosine theta plus a. That's just from up above. We already have an understanding of why that works. In the next step, what I've done is I've taken this cosine theta plus a and I've expanded it right here, simply using my sum and difference formulas, those sum and difference formulas that we used way back when, okay? So we've got our sum and difference formula. That's all we did there. Remember, that was just since it was a cosine and a sum, it was our cosine, cosine, sine, sine, and then we changed the sign from the plus to the minus. In the next step, all I did was distribute the r. Okay. Then I used my conversions, the other values that we had up at the top. Remember, these are just straight from the top. The x prime is the r cosine a, and the y prime is the r sine a. Okay, those are just straight from up here, remember. Then we can substitute. Okay, if you're not seeing that substitution. What we did was we took this r cosine, the r, and the cosine a, and then the r and the sine a, and that became this x prime, and the r sine a became the y prime, and that cleaned up my entire equation. That was exactly where we wanted to go. if you look over here on this right-hand side, I've done the exact same process with the y. Okay, so once again, I took the sine theta plus a. I did my sum and difference formula again. So these are the exact same proofs. Then we distributed the r. That's all I did. And then I used the same conversions from up above. So now I have my r cosine a. And here was my r and my cosine a, so it could become an x prime. And I had my r sine a, and there was an r and a sine a, and it became my y prime. And then I was all done again.